This is Supriya, and welcome to my midterm evaluation for web development. I built this application called Study Sprint Matcher. It helps students find study partners for focus session. But more importantly, I'm going to use this to walk you through everything we have learned this semester. We'll start with the fundamental building blocks, see how they all connect, and then I will show you some live coding to demonstrate how everything works together. Before we start, I would like to show my website so you can get more idea. So first you see three cards, motivational quotes, sometime just so you're aware, and this is the fun part where you can create study session. You can enter the subject where you would like to study online or offline. If you just click on offline, you can enter the location, for example, library. And then you can also select the time, how much you want to study. Here you can see your progress, the sprints which I have created, and the active sprints. As you can see, it got over. But usually there would be a join button if you want to join any active session, and then when you click on view all sprints, it will give you an option to select or browse. For example, you can search subjects here, and then you can decide online or offline session you would like to join and just click on search. And this is just pretty basic login and logout option. That's about it. So we'll be using my diagrams so it is more clear. So web development has three core technologies that work together: HTML, CSS, and JavaScript. And I like to think of this as a building a restaurant. So let me explain what I mean. So we'll start with HTML. This stands for Hypertext Markup Language. Using our restaurant analogy, HTML is like the floor plan and room layout of the restaurant. It defines what each space is. So this is the kitchen, this is the dining area, this is the entrance, and this is the restroom. And in web development, HTML defines the structure and meaning of your content. You use tags to mark a different section. For example, you can see this, like you have header which defines your top section. You can just imagine restaurant entrance, then navigation windows, and main tag just for your primary content, and footer for your bottom section. These are called semantic tags, and semantic is just a fancy word for meaningful. Instead of calling everything in div tag, which would be like calling every room in the restaurant just a room, we use specific tags that describe the purpose. Why this is important? Well, imagine someone visually impaired using a screen reader. If we use semantic tags, the screen reader can say, you are now in the navigation section or you are in the main content area. That helps them to navigate. So it's important. Apart from that, search engine uses this structure to understand your content better. If you want good search engine optimization, use semantic HTML. And there is one more rule which our professors has drilled down to us, is that every page must have exactly only one H1 element. That's your primary heading, like the main sign of your restaurant. And I forgot to mention, but you should be using only MDN documentation because it's the only resource that strictly follows the official web standards. So, yeah, that's your HTML. It's your foundation, your structure, or your semantic meaning. Okay, now let's talk about CSS. CSS stands for Cascading Style Sheets. Going back to our restaurant analogy, if HTML is the floor plan, CSS is the interior design. The paint colors, the furnitures, the lighting, and the ambience. CSS control how everything looks. Apart from that, we have also learned about CSS specificity. This is super important because it determines which styles actually get applied when you have conflicts. So inline styles have the highest priority. That's when you write style equals directly in your HTML. And then ID selector, class selector, element selector, which has the lowest priority. When style conflict, the more specific one wins. We are also gonna use Bootstrapify, which is a CSS framework. Bootstrap gives you a grid system that makes responsive design really easy. So, for example, when you write column large 4, here's what it means. Call This means column LG means large. That's for desktop computers. 4 means just use 4 out of the 12 columns. So 4 out of 12 would be just one third. You have, for example, I had 3 cards here side by side. And the beautiful thing is this automatically adapts on tablet and on mobile phone, which will just make your card stack vertically. Same HTML code. Bootstrap handle all the responsive behavior. And one more detail I would like to highlight is which is extremely important, where you load your CSS and JavaScript in your HTML matters a lot. CSS goes in your head section. Why? The browser will not render the page until CSS is loaded. You do not want user to see a flash of unstyled content. Imagine walking into a restaurant for a second and all the walls are unpainted and there is no furniture. That's why we added to the head section. So CSS loads first and then everything renders properly. And JavaScript goes at the end of the body tag. This way, the page can render first and then shows the user the functionalities. So that's about CSS, visual representation, layout, and responsive design. Now we get to JavaScript. This is where things get really interesting. In our restaurant analogy, if HTML is the floor plan and CSS is the interior, JavaScript is like the electricity, or you can also say the waiters, kitchen staff, the whole operation that makes the restaurant actually function. JavaScript makes your page interactive and dynamic. When you click a button and something happens, that's JavaScript. When you submit a form and it validates your input, that's again JavaScript. We learned modern JavaScript, which is called ES6. Let me show what makes it modern. So, old JavaScript uses var. We don't use that anymore. It has weird scoping issue and cause bugs. Modern JavaScript use const and let. Const is for the values that won't change. Once you assign it, you cannot reassign it. And let is for all the values that will change, like the number of the customers currently in the restaurant. Use const by default, only use let when you know the value needs to change. Next, modules. This is how we organize code. The old way had serious issues. Problem number one, putting all your code in one giant file. Imagine having the entire restaurant operation manual in just one document. Thousands of lines, recipe for the soup, how to greet customer, closing procedure, all mixed together. Impossible to maintain. Using multiple script tags, everything becomes global. It's like having all the kitchen recipes scattered everywhere. And chef's ingredient randomly. But this issue is resolved with modern JavaScript using ES6 module with import and export. Think of it like this: the kitchen has a recipe book. When the wait staff needs to know what's in the soup, they import that specific recipe, clean, organized, and no confusion. One file export what it wants to other, and other file import only what they need. For this to work, you need this very important information. Type equals to module in your package.json file, and type equals to module in your HTML script tags. This tells the system use the modern module system. And I can show you the example as well in my code. I made this code, and then I was using that code in main.js. Here you can see it was imported a very specific information from my code.js to main.js file. Okay, now the most important concept we learned: promises. Let me explain promises really carefully because this is absolutely fundamental to modern JavaScript. JavaScript operation that takes time, like fetching data from a server or reading a file or anything to do with database, they return promises. Here is the problem promises solve. Imagine you are at a restaurant, you walk to the counter and order food. The old synchronous way would be you stand at the counter, you wait, and then once your order is cooked, you get the food. But meanwhile, all your time got wasted just for waiting. That would be terrible, right? But the modern asynchronous way with promises, you order food, they give you a buzzer, this little device that will vibrate when your food is ready. Now you're free. You sit down, you chat with your friends, or you check your phone. You you are doing other things. When the buzzer vibrates, you go get your food. So the buzzer here is the promise. It's a placeholder that says your food will be eventually ready, but you don't have to stand here and wait. JavaScript promises work exactly the same way. When you fetch a data from a server, that takes time, maybe 50 millisecond to maybe 500 millisecond if the connection is slow. JavaScript does not freeze your entire application while waiting. Instead, it gives you a promise, a placeholder that says your data will arrive eventually, your application continues running, and everything stay responsive. Okay. And we use two keywords: async. Async marks a function as asynchronous, meaning it will use promises. And then next is await. Await pauses the function at the specific line until the promise resolves. Here is the key: it only pauses that function. The rest of your application keeps on running. I'm going to demonstrate this in the live coding section, and you will see exactly how this works. Now, let me show you how all these pieces connect in a full stack application. In our restaurant analogy, think of it this way: the dining area is the browser. This is where customers your interact, they see the menu, they make orders. This is your HTML, CSS, and JavaScript. The kitchen is the server, the also known as backend. This is where order get processed. The kitchen receives order from the dining area, prepares the food, send it back, and we built our kitchen with Node.js Express. And the last one, the pantry or storage room, is our database. This is where ingredients such as your data are permanently stored. We use MongoDB for this, but you can use any database. Let me trace what happens when a customer orders something. Step 1: Customer places an order. In web terms, they click a button. JavaScript make an HTTP request to the server. The order reaches the kitchen. The server, that is Express, receives the request, and the kitchen checks the pantry. Um, the server queries MongoDB if that data is available, and the pantry provides the ingredients and which will be sent in document format. The kitchen send out the prepared dish, and the server sends JSON data back to the back to the browser. So it would send from server to the browser, and the customer receives their food. JavaScript takes that data and display it on the page. All of this happen in about 50 to 100 milliseconds. The customer never leave their seat. The page never refresh. This is modern web architecture, asynchronous data flow between three layers. Now let me show this working in the actual code. So I'm just gonna open VS Code, and this is my study sprint matcher. Before we dive in, let me walk you through the project structure so you understand how everything is organized. So the first folder would be front end. This contains everything that runs in the browser, the dining area of our restaurant. So inside front end, we have index.html, sprints.html, login.html, CSS folder for styling, JavaScript folder for interactivity. And now let's check out backend folder. This contains everything that runs on the server, the kitchen. Inside backend, we have server.js. This is the main server file. It starts Express and set up routes. And db.js is just the MongoDB collection. And then we also have routes folder, which contain our API endpoint. Think of root as different section of the kitchen. One handles sprint, operation, and one handles authentication. Also notice package.json in VS Code. Let me open that. This line right here, type module. This is what enables modern import and export. Without this line, your import won't work. Also dependencies. These are the libraries we need. Express for the server, MongoDB for the database, and many other things. The application is already deployed on render.com, so we can see it running live. So I want to show you what happens behind the scene when you use this application. So I'm just gonna use developer tool, which is like having an x-ray vision into your web page. You can just right click on it and just click on inspect. So the network tab shows every single HTTP request that browser makes, every file it downloads, every call it makes. And the console tab shows JavaScript output. We will be using this a lot for the live coding. So let's start with network tab. I'm just gonna refresh this page, and I want you to watch the network tab carefully. So let me explain what just happened. First, the browser asked for the HTML file, and the server sent it back. And then it sent the CSS file, and the browser, which is a script file, and then main.js file, code.js file. And all of these are static file. The server just sent the file as it is. But now look at this one, the sprints. And it says fetch. This request is different. Look at the type column. This isn't a file request. This is a JavaScript making an API call to get data. Let me show let me show you what came back. If you just click on it, okay, sorry, went to the wrong. Yes, sorry. So just click on response tab. Look at this. The server sent back JSON data. Not HTML, not a style page, just raw data. An array of object. Each object represent one study sprint. You can see the structure, username, subject, location, duration, and participants. This is pure information. Now, if you look at the page, you will see nicely formatted cards with all the information displayed, which we saw here. JavaScript took this raw data and built the visual representation here. That's the key difference. The server provides the data, JavaScript creates the display. This is what we call client side rendering. Let me show you the code that does this. Again, let me open my VS Code. We'll go to front end and then just click on JS. Let me scroll down to the find main.js. Okay, so we'll just select load all sprints. This is the function responsible for fetching. We'll just mark this. Responsible for fetching data from the backend and displaying it on the browser. Let me walk through this code carefully, line by line. I've increased the font so you can see it nicely. The word async is really important. It tells JavaScript this function is going to perform asynchronous operations that take time. When you mark a function as async, it means you can use a wait keyword inside it. And line 2, try. We are starting a try catch block. This is just for error handling. If anything goes wrong, we'll catch it instead of crashing the whole website. Now line 3, constant response equals await fetch, and this is the API URL where my project is deployed. Okay, this is where the magic happens. Let me break this down piece by piece. Fetch is a browser API, a built-in function that makes HTTP requests. We are giving it a URL, our backend API endpoint. So what does fetch return? It doesn't return immediately. It can't, because making a network request takes time. Instead, fetch returns a promise, a placeholder. The await keyword, the await keyword says, pause this function right here. Wait for the promise to resolve. Wait for the server to respond before moving to the next line. While this function is paused, the rest of your application keep on running. Other JavaScript can execute, button clicks still work, animations still play. That's the power of promises. I'm going to demonstrate this in the console in just a minute and you will see exactly what I mean. But for now, let's continue. Line 4, constant sprint equals await response.json. Another await. The response came back from the server, but it's in the raw text format. We need to parse it, convert it into JavaScript object, and the JSON method does this parsing. And parsing also takes a tiny bit of time, so we await it. After this line, we finally have usable data, an array of sprint objects. So display sprint, we pass that data to another function that handle rendering it to the page. Let me show you that function. This is that function display sprints. This function takes array of sprint and creates HTML for each one. We are using string literals, string with backticks. This is what I mean with dollar sign. Oh. That let us embed variable. See the syntax dollar sign curly sprint dot username. This insert the actual username value into the HTML string. We are building HTML dynamically based on our data. Then container.h inner HTML equals put this HTML into our page. This one. This is DOM manipulation. DOM stands for Document Object Model. It's the browser representation of HTML. We are modifying the HTML after the page has already loaded, creating new elements, inserting them all with JavaScript. And back to the error handling. Let's go back here. So if anything goes wrong, the network fails, the server crashed, the JSON is invalid, the catch block handle this. We log the error to the console instead of letting the application break. This one. Always wrap asynchronous operation in try catch blocks. It makes your application robust. That's the front end code. Now let me show you what the server is doing. So we'll just maybe go to backend and we'll select roots and let's just say sprints.js. This is the backend, the kitchen of our restaurant. This file contains the server, express route, the different API endpoint. Let me show you the route that handles getting all sprints. So I have already highlighted this router.get slash this define a route. When the server received a get request to API sprint, this function, let me highlight this, the seventh line, get execute. The function received two parameters, request and response. Request is the object, it contains information about what the browser asks for, parameter, headers, and all of that. And response is the object, we use this to send data back. The next line is constant db equals to get db. We get access to our MongoDB database connection. Line third, constant sprint equals await db.collection sprints dot find to array. This is the database query. Let me explain each part. db.collection sprints access the collection called sprint. In MongoDB, collection are like tables in SQL but more flexible. The find, this searches for documents. We are passing empty parenthesis, which means no filter, get everything. We need everything. To array, MongoDB returns a cursor by default. We convert it into JavaScript array. This is an asynchronous operation. We are waiting for MongoDB to search through potentially thousands of documents. So we await it. And by now we know what await means. And line 10, response.json sprint. We send the data back to the browser. Respond.json automatically formatted as a JSON and send the correct header. Notice what we are not doing. We are not creating HTML. We are not rendering a web page. We are just providing data. The front end, the browser handles all the presentation. This is a client side rendering. The server is lightweight, it focuses on the data and business logic. Now, let me show you db.js. This file handled connecting to MongoDB. When the server starts, it calls connectDB function. We create a new Mongo client, connect to it, and store the database reference. MongoDB store data as documents. Each document is essentially a JSON object. I think I have notes from that. Yeah, here it is. In our case, each sprint document has this field, ID, username, subject, location, duration, participants, creation date. The underscore ID field is special. MongoDB generates this automatically, and it actually contains information about timestamp, which is why sorting by ID gives you chronological order. MongoDB is flexible, unlike SQL database where every row must match a strict schema. In MongoDB, each document can have different fields. This makes it perfect for applications that need flexibility. That's the backend and database. Uh, uh, this was I was talking about. Now, let me demonstrate how promises actually work with live coding. So I'm already in console tab. I'm gonna just make it more big, maybe a little smaller. Sorry. Everything I am about to type will be right here in the browser. Everything I will be right here to show you what a promise actually behaves. Let me create a promise manually so you can see it in action. I'm going to type this slowly. So I'm gonna just const I will say testing test promise. I'm creating a new promise and it takes a function. So new promise. Inside the promise, I'm using a set timeout. After every 3 seconds, resolve the promise with this message. Now, closing the parenthesis. Now, let me immediately check what my promise is before those 3 seconds pass. So, for that, I'm just gonna type console.log checking promise immediately. Look at that output. Promise pending. Here it is. This is the key. The promise exists, but it hasn't resolved yet. The data is not ready. Now let me await it for it to resolve. So for that, all you need to do is I'm just gonna use await. This will pause right here until the promise resolve. Should take about 3 seconds total from when we created, and then we wait for it to resolve. Const, okay, const. And then I'm just gonna add a statement. When it is resolved, it should say the statement. So console.log result. Okay, see the output. The promise went from pending to fulfilled, and this demonstrates the promise lifecycle. In real application, instead of set timeout, you would be waiting for server responses, database queries, file read, but the pattern is exactly the same. You get a promise, you await it, it resolves with something. Okay, now let me show you something that might surprise you about how JavaScript handles asynchronous code. I'm going to type server console.log statement, some synchronous, some asynchronous code. And let's start with the first one, just a regular synchronous console log. Okay, sorry, start. And for the second line, I will set a timeout which is asynchronous. It schedule this log for like 3 seconds, 4 seconds. So just gonna write now just gonna copy this code. Another set timer, let's just schedule for 1 second. Mhm. And now the final one, which would be a regular synchronous log. Now just watch how the order they will print. So 3 after 1 second and 4 after 3 seconds. The asynchronous operation ran after all the synchronous code finished. JavaScript has a rule: complete all asynchronous code first, then handle asynchronous operation. Even if its async operation is ready, even if it's scheduled for like 0 millisecond, it waits for synchronous code to finish. This is called event loop. Understanding this will help you debug timing issues and write better asynchronous code. Now, let me just fetch actual data from our backend API. I'm going to build this request step by step so you can see each part. So, again, let's just clean this. I'm making a fetch request to our backend API, the sprints endpoint, using await, which means JavaScript will pause right here until the server responds. So, let's just type pause. Let's just press enter. Good. Now let me just check the status if the request was successful or not. So for that we just write console.log. Says 200 means success, okay is true. Perfect. The server responded successfully. Now I need to get the actual data out of this response. The response is a raw text. I'm using the JSON method to pass it into the JavaScript object, and this is also asynchronous. Parsing takes time, so awaited. So let me just show const sprints equals to await response JSON. Now we have the data. Let me see how many sprints we got. Let's say console.log total. Okay. Over 1,000 sprint. That's a lot of data. Now let me look at the structure of one of the sprint, like how it looks like. So we can just use slicing to get one of the first responses. First sprint of the date. Okay, that's the first sprint or the first element in the array. Let's just expand it. This is exactly how the data is stored in MongoDB in JSON format. It has ID, username, subject, location, duration, participants, and the created date. Now, let me just filter for only online session. I'm curious to know how many online session I have. So just const and we'll save it as online session sprints. Using the filter method, this goes through each sprint represented by S and keeps only the ones where the location equals to online. So S dot location. Let's keep it as online. Now let's just print using console.log. Lines prints. And session dot length. About 505 out of 1000 are online session. The filter method is one of the JavaScript array methods, super powerful for data manipulation. Tests demonstrate the complete flow. They fetch the data from the server using promises, parsed it, and manipulated it. Just one more live coding demonstration. I'm going to modify this web page using JavaScript right now while it's running. Watch the heading at the top of the page. So let's just say const heading. Okay, so it's a wrong code. So for do that, I'm gonna use document, which is the browser API for accessing your HTML, and query selector let me find elements using CSS selector. Since I'm using H1 element, um, it should be easy to find. As you remember our rule, just have one H1 throughout the page. Query selector. Query selector. Let me see what text it currently has. For that, we would be using text content property. So console current, and this should work. Switch, it says browse study sprints. Now watch the base. I'm going to change this text using JavaScript. Setting text content to a new value with the total count included. So let's just do that. Heading dot text content equals to browse study, maybe just sprints 115 total. Did you see that? The heading changed instantly. I modified the HTML after the page loaded. No refresh, no reload. Let me change the color too. Let's just say modifying the CSS color property. So it would be heading dot style dot color. As you can see that it's red. This is DOM manipulation. JavaScript can reach into your HTML and modify anything. Change text, change colors, add elements, remove elements, anything you want. This is what makes modern web application feel so interactive and responsive. Let me put it back to normal. You can see the change instantly. Resetting the color to empty string bring back the original CSS. So just an empty string. Back to normal. That's the power of JavaScript and DOM. Apart from this, we are also taught some important concepts such as ESLint. This catches error while you type before you even run the code. It shows a problem. I can show you. There is one more called as prettier. This automatically format your code, keep everything consistent and readable. And the one more is Git version control. Tracks every change, collaborate with others, deploy and easy setup. So this is something you should use. And some critical practices we have learned is never test HTML by double clicking files. Always run a proper server. JavaScript module require the HTTP protocol to work. And always hard refresh when testing. That would be Command Shift R on Mac and Shift F5 on Windows. This clears the cache so you see your actual latest changes. And never, this is extremely important, never commit your password or API keys to GitHub. Use environment variables. That would be on .env file. Store secret in a .env file and process them with process.env. The env file get added to git ignore, so it never gets uploaded on GitHub. This protects your credentials. Okay, let me summarize what we have covered. We have covered core technologies like HTML, which provides semantic structure, the foundation. The CSS controls visual representation. We use Bootstrap 5 for responsive design. JavaScripts add interactivity. We use promises to handle asynchronous operations. Express creates the backend server. It handles HTTP requests and provides API endpoints. And MongoDB, which stores data in a flexible JSON documents. We have also covered architecture, and apart from that, we have covered how the browser requests data, the server queries the database, and all those informations. Okay, this is deployed on render.com. The backend runs there. The database is on MongoDB Atlas. The complete source code could be found on my GitHub page. This is my GitHub page. And I have also created a post about this on my LinkedIn. So this has been my web development bit demonstration. Thank you so much for watching and have a great day. Bye bye.